Okay, so today we're going to look at not recording, sorry. Today we're going to look at LED strips. And so we have these LED strips. This one is actually, these are considered to be what we call addressable LEDs, where you can individually control each LED on the strip. This one right here is an RGBW, which can do red, green, and blue, and then white as well. And we'll talk about all the colors more later. But the reason we use red, green, and blue is because that's how our eyes work. And so if you have any combination of red, green, and blue, can create any color that you can see for the most part. It's probably not quite there, but you have a sensor for red, a sensor for green, and a sensor for blue in your eyes. And so if you create any combination of red, green, and blue, it'll trigger each of those sensors to make them see a color. And so, like, for example, if you want to create the color yellow, well, you're going to send a red light and green light, and it's going to trigger both of those sensors in your eye, and your eye is going to see yellow, even though what it's really doing is seeing red and green. And so that's also how your screen that you're looking at works. It's got each pixel is a red, green, and a blue. And so you can see there's areas of the screen that are kind of whitish, and those are all three are on right there. There's areas of the screen that are dark, and that's where they're all turned off. And then anything else is a combination of all those in some manner or another. And that's how our eyes see color. Okay, and so with a red, green, blue RGB LED, if you turn all three colors on, you see white. You can turn just one color on and see just one color, and then you have a whole other range of colors you can see as well. So this is another example here. You can see that they have 3 pins on them, and in this example here, you can see it's just connected to the first part, and then what happens is you have a signal wire. Look at this. So the one that's here is actually different than the ones that we have. So I would be careful wiring them like this. So the ones like this one, for example, you have to look very carefully. It says 5 volt, and then D in, or the signal in, and then ground. Whereas this one, it looks like the signal one's on the edge, and then the 5 volt in the ground, or the 5 volts in the middle. So I don't think I've ever seen one like this before. Usually the signal one's in the middle. And to connect them, you're going to have some kind of connector like this that has like the red and the green and the white potentially. And so red would be the 5 volt, green would be the signal, and the white one would be the negative. Okay? And so you can even just stick the wires, jumper wires, into here and connect them to the breadboard. So anyway, you send the signal to the signal pin, and the first LED is going to read the part of the signal meant for him and remove that part of the signal and transmit the rest of the signal to the next LED, on and on through the strip until each LED gets its instructions. That's basically how it works. Okay, so in order to do this, though, we have to write some code. And so the first step is we have to include our Neopixel library. So there's a company called Adafruit who's done a lot of work with these and created lots of resources and sells them. And so they've created a library called the Adafruit Neopixel library that's very useful. And so we're going to go ahead and paste that in here. Let's see, we'll go libraries, type in Neopixel. Nope, it's not showing up there. This one we'll use later. Alright, so we'll just type in ourselves. Alright, make sure we got that. And so now we have to create an instance of this object. Okay. Oh, there you go. I typed it in wrong. What did I do wrong here? Let's look at the example here. Adafruit underscore, the P is capitalized. And there you have it. Okay, and so from here, what we do is we're going to create some, we'll define some constants here for the number of pixels and the pin that it's connected to. So we'll say, so we're going to define the number of pixels, and that will be maybe, so you'll go ahead and just count how many are on your LED strip, whether you have 5, 10, 20, whichever. We'll go with 10 for mine. Probably yours might have 20 or 50 or whatever you have. And then we also want to connect it to a pin, right? And so say it's on pin 6, pin 8, whichever. And now we make an instance of the Neopixel object. So if we look here, we create a variable that's defined as an Adafruit Neopixel strip. And then we're going to go ahead and define it using these quantities that we added in. Okay, so I'm just going to go ahead and type this in real quick, and then we'll review what it says. Okay, so we've got this typed in here. So this name's like the type of the object. This is the name of our variable. So we have a variable called strip. Oh, I have a typo here. Let's see. Oh, gotta have the underscore. There you go. And then we have the this is what we'll call constructor, and we're basically creating this object and we're initializing it. Sorry, I made some typos when I was putting this in clearly. But so within our constructor here, we send 3 pieces of information. First, we send the number of pixels, so how many pixels that pound define we create right there, the pin that we're connected to, and then here we say what color format we're using, and so we're going to be using green and then red and then blue, so GRB, and then this is kind of the rate that the data is being sent at. Wouldn't want to tweak with these things. Really, you're going to put this line exactly as is, and then you can make your key changes on these 2 lines here. Okay. From here, we've declared it. We've got the number of pixels on there. We've got our LED pin, and now it's time to start controlling it. So now in our setup, we're going to say strip.begin, and this just kind of initializes it. Okay. And so whatever word we called it, if we want to call it my LED strip or something like that, you could do that instead. So you could change the name to be whatever you want. Okay. But we're going to begin it, and we're going to also show it, so which basically displays what whatever is currently it's programmed to do, which is nothing at this point. And so this is going to turn it off. And so let's say you had a program running and the LEDs were on and you turned it off, but you still had power to it. Those LEDs would still be on because they haven't been told to do something. So this just initializes them to off. Okay, and so now we'll start off by just blinking a single LED. And so the way that we're going to do that is right here we're going to say strip dot set pixel color. Then in parentheses we'll say which pixel number, and then we're going to create this, pass this color object, and we're going to turn all 3 colors on to full, which is going to cause it to turn white. Okay, and then we're going to do strip.show. Okay, and if we run this code, what we'll see is that a single LED will turn on. Okay, so we actually have an error here. It should be strip.color. There we go. And then I'm also going to change this to 12. Okay, now we run our simulation, and you can see that first one just turned on. Alright, let me stop it and run again. You can see that first one just turned on. Okay, and so now I'll show you the second part of blink. Alright, and so we're going to add a short delay here so we can see that it was turned on. We'll go 500, and now we'll do the same thing, but we're going to set the color to 0, and that will turn it off. Okay, and so we're going to instead do 0, 0, 0. And then when we run this code, we can see now that our LED is going to be blinking on and off. Nope, we got to add another delay there. So we want to add a short delay here after we turn it off so that we can see it turned off. And now I've got it blinking. Okay, and so that's how we blink a single LED. We might want to also blink all the LEDs. In order to blink all of them, let's add this delay back at the bottom. What we need to do is we need to go through and set the color of all of them. And so to do that, we can use a for loop. So we can say for, and we can say int LED index is equal to 0. So we're going to start off at 0. We're going to say LED index is less than the number of LEDs, or we said pixels maybe? Yep, number of pixels. And then we will increment that value. And so we will do this, and we will wait to show it until we've done all of them. And we can have fun and kind of tweak those things later, but for now we've turned them all on, and we're going to do the same thing again to turn them all off. Oops, so we want to put right here instead of the 0, I want to use LED index. Alright, and so here's where we turn them off. So we got the same loop, but this time we're going to set the color to be 0. Okay, so we'll run this code. And now it should blink the entire strip instead of just the one. See if we made a mistake here. Oh, it's just doing 2. I wonder why just 2. Let me look here. Number of pixels is 12. This might be just an error with the simulation, I hope. I'm not sure why it's only doing 2 of them. That's interesting. Okay, well, anyway, that's how it's supposed to work. It should be turning them all on. I think that the simulation is only going to do the first 2 here instead. We can also mess around this. So if we move the strip.show into here, and then add a short delay in here, like maybe 50, then what will happen is we'll see them all turn on like one at a time, and the same thing down here. So now we go through and we turn each of them on, but each time we turn it on we show the strip, and then we wait a little bit. And so this is different. Before we set all the LEDs and then showed it. Here we're going to set them one at a time and show it as we turn them on, and we'll see that it is going to act differently. Now this simulation unfortunately isn't cooperating to let us see the full effect of it, but oh, there it goes. Oh, that was interesting. For some reason it's missing that third one though. That's so weird. I wonder if I've got a mistake here. Set pixel color. I don't think there's any mistakes here. So that'd be interesting to see if it's behaving differently on a different one. But they should stay on, wait half a second, and then turn off, and then wait half a second. But anyway, it's kind of working now. I think this is just kind of a bug in the simulator. Maybe it's not, I don't know. But if we come back to here, so what we've done so far is we figured out how to blink one of them. We figured out how to blink all of them, and now I figured out how to kind of turn them all on, wait, turn them all off, where they kind of phase in and then phase out. Okay, so let me know if you have any questions. Give this a try, and next we will look at controlling them with a sensor.